Okay. So good afternoon, everyone. As Shadi aforementioned, I'm a student from Politecnico di Torino, and in the context of my thesis conducted here at the University of Liège, I did this work about the estimation of tall timber building component service life. So we are all aware of the European goals of decreasing the carbon emission of 55% by 2030 and achieving carbon neutrality by 2050. And us as a construction sector, we are responsible for more than a third of this carbon emission. That's one of the most used solutions, and the reason also why we're here today is to shift from construction technologies with high carbon content, such as steel or concrete, to low carbon content or negative carbon content technologies such as timber. Timber enters the carbon life cycle as a tree, absorbing the carbon and stocking the carbon, storing the carbon. And throughout the life cycle of the timber, so as a tree, later as a component, as a manufactured product, as a building component, it keeps this carbon stored until, with demolition, in most of the cases, this carbon is back released into the atmosphere. So the key concept to understand what is the efficiency of timber, the timber solution, in order to decrease the carbon in the atmosphere, so to reduce and to achieve the European goals, is to understand how long actually this carbon is stored. So for how long the cycle stores the carbon within the buildings. And the tools to evaluate is the life cycle assessment. According to the standards, we should consider 50 years for buildings, while for the components themselves, there is no standard, but what we can do is we can rely on manufacturer data, such as product data sheets. However, there's a huge difference between the predicted life, so the theoretical value provided by manufacturers, and the actual life that a component can last for, as was highlighted by Compari in 2023, where he investigated about the actual life service of components, of a set of components for traditional construction. So our question was at this point, what are the actual life service for not traditional construction, but for timber construction? So in order to reply to this question, a survey was conducted based on knowledge and experience of the construction sector actors in a period between October and will be available until summer 2024, focusing mainly on mid-rise and tall buildings. Also mid-rise buildings were involved, were included because of a lack of data of tall timber buildings. And 14 different components were identified between the structure, envelope, and sublayer of the envelope. So the surveyors was asked for each of these components a range of life service, so a minimum and a maximum value. And finally, the data were processed statistically, and an average value was obtained for each of these components. So with 103 total responses, it was possible to translate the traditional construction graph of Compari into a timber construction graph, and immediately we can see how actually there are many similarities, and most important, also in timber building, in timber construction, the structure can live up to 150 years. Going more in detail, we can distinguish between three main groups. A group with a replacement rate of about 15 years, which is mainly composed of finishing, so internal finishing, claddings, external claddings, as well as glazings. A second group with a mid life service of 30 years, composed of envelope sublayers, such as fire protection layer, waterproofing and vapor barrier, and insulation. And finally, the most important result, the structural group, so frame timber panels, solid timber panels, columns and beams, which can live up to 150 years. Also, some comments were added to the survey by surveyors, and this comment highlighted also some lacks, such as, for instance, not considering the importance of considering moisture as a very influencing factors in the actual life of components for timber. Also, construction methods quality, as well as some other similar works carried out about actual service life. So, as additional lacks that we identified, for sure, the sample dimension, which is very small, 100 responses is not enough to reliably represent the construction sector. Thus, the results should be addressed as indicative results rather than conclusive results. Also, the cost share, so the y-axis of the graph was not assumed, was not assessed, as well as we didn't differentiate for the same construction technology among different timber materials. So, for instance, we didn't differentiate for a column between a LVL or a glulam column. So, suggestion for future works, of course, to expand this sample size to include the cost share, as well to differentiate among the different construction technologies. And as mentioned already, the main findings was that actually timber building can last to up to 150 and maybe even more years. So some considerations that followed. First of all is, should we include this value in the LCA? So standards suggest 50 years, but to properly address the LCA, maybe at this point we could even use this value of 150 years. And the second consideration is what happens actually at the end of life of timber, because in the EU, less than a third of this timber is recycled, while the remaining is either recovered, so burned to generate energy, or landfilled. So this means that 2/3 of the timber and the carbon stock in this timber is in the short term released back into the atmosphere. So in order to achieve the European goals of 10-30 years, timber, as it's treated nowadays, can be a solution. However, if we want to expand, to consider the global challenges for the future, we should shift from a short-term carbon reduction to long-term carbon removal. And also, a second question is, even if we manage to, let's say, achieve 80-90% of timber recycling, after 200 years, 300 years, when this recycled timber reaches its end of life, what happens also, what will happen to this timber? So in conclusion, this work, together with other similar works, shows, I like the importance of the difference between predicted life and actual life. And this work can act as a basis in order to properly assess the life cycle impact of buildings and their components, and thus to evaluate what is the suitability of timber as a solution to current European goals and also for future global challenges. And finally, also focusing on the weaker components, or those components with a shorter lifespan, can be a topic in order to further enhance this technology impact. The results will be shared with everybody who replied to the survey, and also if anybody wants, let us know. Here are the references, and today's meeting will be shared together with the presentation, both in the subgroup 1 Drive and the subgroup 2 Cloud. Thank you for your attention, and if you have any question,
Thank you, Tommaso, for the presentation, and thank you for the detail of reminding us about our shared folders. Now we will have time to exchange with you all. Don't hesitate to ask questions. I will just ask you please to make sure that your name appears and that you raise your hand, digital hand, so that we can have